Hi folks, Astronomy Live. Tonight, I'm hunting for an asteroid. 2018 VX-1 is flying by Earth this weekend, and it's going to be about as close as the Moon at its closest approach. But it's a very small asteroid in the 10-meter size category, give or take. So it's proving to be quite a challenge to try to find it. Even with my telescope and my camera cranked up to maximum sensitivity, I'm having a lot of trouble locating it right now, unfortunately. But that's okay. It's still a good evening to celebrate, because GitHub has restored SatTraker. It's back up. They have overturned the false DMCA strike fraudulently filed against my software, very likely by Planet X 2016, Nibiru Channel, and company, who falsely claimed my software was stolen. Well, that's all taken care of now. So, if you go to the GitHub page, which is linked in the video description, you can once again download all of my programs, including SatTraker, which was the one taken down by the false DMCA strike, and I've updated it. I've acquired a small Celestron telescope to test out the universal driver compatibility of the program and troubleshoot any issues with that. And I've squashed one bug that I found with ASCOM tracking, and it seems to be working at least indoors. I haven't tried it yet with that scope outside, but I definitely fixed one major problem there with the ASCOM compatibility. ASCOM is a universal driver set, so this is going to give me the opportunity to test it out on a telescope that is representative of a lot of other telescopes, a much wider range of hardware than is represented by my LX200 Classic, which is quite an old telescope and perhaps not as common these days. Newer LX200s have an expanded vocabulary, and while they should be compatible with the LX200 command set that I used in that program, there could be some issues there. So all these streaks you're seeing, these are all stars the telescope is tracking based on the asteroid's orbit, and it should be somewhere in the view, but it's supposed to be no brighter than about magnitude 16.8, which is extremely dim. Anywhere around magnitude 17 and dimmer is quite a challenging target for this telescope, especially given the speed the asteroid is moving. So I'm not sure that I'll really be able to find it, unfortunately. I don't see anything here that is unambiguously the asteroid, put it that way. But even if I can't find that particular asteroid, there's still plenty of other targets to take a look at tonight. The telescope is out as aligned right now because I figured, given the speed this asteroid is moving, polar alignment wouldn't really matter, actually. The principal direction the asteroid seems to be moving in right now is declination. And so as a result, even if the telescope was aligned to the Earth's axis of rotation, it would be driving in declination most of the time anyway. So polar alignment didn't really matter for tonight, but it does mean there is field rotation, and the asteroid is in the north. The declination's not too high, but it's high enough that you can see some interesting curves there. It's about 33, almost 34 degrees declination right now. Yeah, 34 degrees, almost 34, yeah, 34 and a quarter at this point. It's moving fast. So, I don't really see any sign of it. And I'm not terribly surprised by that, to be honest. I knew this was going to be a challenging target. But it's going to be the closest of 3 asteroids passing by Earth this weekend that have been featured in certain tabloids. Some of which are claiming that they are a threat to hit Earth. They could strike Earth at any moment. No, not really. They're all going to miss. This is the closest of the 3, and even that is still so far away, at about the distance of the Moon, that even a telescope like mine has a huge amount of difficulty trying to detect it. So, the asteroid should look like a star. It should look like a solid dot, although really you can see how the stars are a little bit wobbly. That's due to limitations in the encoder's resolution for this telescope, or rather the coordinate format used by this telescope. You can't specify a fraction of a second of arc in right ascension the way this telescope's set up. It's just not possible. So as a result, it's kind of jerky in the right ascension axis. It's extremely jerky in the right ascension axis, which causes it to wobble a bit in the tracking. So it would look like a wobbly star, really. It wouldn't be perfectly solid, and that makes it even more challenging. That's another reason why it's extremely challenging to try to get an object that dim with this telescope. Now, the Celestron scope that I just acquired, that uses the ASCOM driver set, it does let you directly set the drive rates, which makes it much easier from a programming standpoint. Doing a program like this where you're trying to track an object moving at a variable speed, you can just tell the telescope what speed to move at, and it does it. It just does it. And so you wouldn't get that kind of wobble quite like that with the Nexstar telescope that I'm testing on, but it's got a much smaller optic. It's a 4-inch telescope. This is an 8-inch Schmidt-Cassegrain versus the 4-inch Maxitov that I picked up from Celestron. So it's not as good. No, that's funny. I could claim that's the asteroid. That's not. I'm pretty sure that's a hot pixel that just didn't get subtracted properly. These are 5-minute exposures too, so it takes an eternity to get each picture down from the camera. I'm trying to look for something that doesn't really move image to image, that isn't solid white. If it's really solid white like this, even though it's got a bit of a wobble to it, you see how there's no... If I really just zoom in on this thing like crazy. Okay, so you see this right here, this guy. You can see how it doesn't fall off in brightness towards the edges. It just suddenly drops off a cliff in brightness. It goes from being solid white to dark. There's no smooth, gradual decrease in brightness. In other words, it doesn't have a point spread function. If you look at the star streaks, for example, you can see how they gradually get dimmer as you get further away. They're not. It's not a solid, sharp decrease in brightness like that. And that's because these stars do present point spread functions. The light gradually falls off with pixels further away. What this tells us is that this is not an actual source of light. It's actually a cosmic ray strike or something like it, probably. A bit of radiation that hit the CCD and directly activated those pixels, and so it doesn't respond the way the camera actually would to a real light source. That's how you can tell. That's like the dead giveaway that it's a cosmic ray strike, not an actual object in space. Even at sea level in Florida, this camera's sensitive enough that it will pick up occasional cosmic ray strikes. The other thing about cosmic ray strikes is they will change image to image, so I would expect that this little thing right here, whatever that is, it'll probably go away in the next image, which will be in about 2.5 minutes thereabouts. Get rid of that selection box. So those are just some pro tips there for hunting asteroids. But if we can't find this asteroid, I'm sure I can find a main belt asteroid or something else interesting to look at. If not this one. Could also try to change the pointing direction of the telescope a little bit, search around, see if maybe it's just outside the field of view. Do that kind of thing. Let's see. I'll look on JPL here and just see where the asteroid's supposed to be, according to JPL. So are we now... Oh yeah, we're already at 3... Geez, time's going quick here. 3:12. Oh, you know what? I may have done math wrong in my head. Okay, well that might be a reason why. Yeah, let's search around here. I don't think the telescope's actually pointing in the right direction because I was trying to fix what I thought was an issue earlier, and I don't think it was an issue. I think it was me being silly because I was doing the time zone conversion wrong in my head. I think somewhere in my head I'm still stuck on daylight savings time, and I'm not converting to universal time properly in my head. What's the current universal time? Should be 3:12, right? Someone in the chat slap me if I'm wrong. Okay, so if that's the case, then I was looking in totally the wrong place. That's why I'm not seeing an asteroid. Okay, let's try a new 5-minute image at the right place. The asteroid should be 77 degrees above the horizon right now, quite high, and actually a little bit brighter than earlier. It'll reach peak brightness from my location just before astronomical dawn, but it'll be really low on the horizon by then, of course. But it's still quite high in the sky. So we still got plenty of time. There's no time crunch in terms of it setting anytime soon or anything crazy like that. That's the good news. Also, I am going to change this to, say, correct coordinates. Let's start a new series of images there, just so I remember for future reference when processing the pictures. I think you guys can see my camera control window now, the way I've got it set up in OBS. Yeah, but for... yeah. No, that looks fine. Yeah, you can see what I'm doing there with the camera controls now. That's good. Now you can see the timer. So, on this box on the right, you've got the blue bar gradually filling up. That tells you how long it's going to be until the next picture's ready. And yeah, I am shooting 5-minute exposures here. It's going for maximum sensitivity to try to maximize our chances of detecting this asteroid. So let's see what happens. Maybe I'll have some success now. That would be nice. Yeah, I put on, before I started the stream, I put on these massive offsets on the program where I was telling it, don't point where you think you're supposed to point way over here. Because I was trying to line it up to where the predicted position of the asteroid looked like it was for my location. It seemed like the program was calculating the position of the asteroid wrong. When you're confident that your program is written correctly, 99% of the time, if you think it's giving you the wrong answer, it's not. You're being stupid, and it's giving you the right answer, and you just don't realize it. That's exactly what happened to me just now. That's the problem I faced. The program wasn't doing it wrong. I was doing it wrong in terms of converting from local time to universal time. That was my problem. So, what time is it now? 16 after the hour. Thereabouts. Yeah, we're much closer to the correct coordinates now, with no offsets. That's always good. Okay. So we'll see what happens now. another 3 minutes until the next image comes in. Galactic North asks if I mind if you stream? I'm not sure what you mean by that. What do you mean? I don't mind if you stream. Are you talking about mirroring my stream, or are you talking about doing your own stream? I guess I'm a little confused about the question. So let's see here. While we're waiting, I'm just going to reshare the link to the stream a little bit. See if any other folks want to join. I really don't like the name of this asteroid, to be honest. 2018 VX1. Sounds like nerve gas or something. Yeah, you can mirror this stream, Galactic North. That's fine. I don't mind it. Just if you do, please link back to the stream, because I have links in my video description, particularly to the software itself, the source code. I want people to be able to download that if they want it. So yeah, the program that's doing the tracking right now, you can go download the source code right now. NEOTraker is what I'm using, and SatTraker is back online, as I said, and that's what I'm kind of actively testing now with the Celestron. See if I can get things working. Alright, give me something good. Alright, what do we got here? We got a bright star passing through. Some hot pixels. I don't know. Still don't see anything really characteristic of the asteroid. Unless that's something right here. I don't know. That kind of looks like a hot pixel, though, the way it's lit up like that. It's sketchy. We'll see what the next 5-minute image brings. If anything seems to stay... Sometimes it's easier to tell when you can flip back and forth between two images. I'll actually pull the images into Deep Sky Stacker on the side and flip between them to see if I can tell if anything is remaining consistent and not noise-like. That almost looks like something. If it were a little bit brighter, I'd say it's definitely something, but it's not. That could just be a random cluster of noise that happens to be bundled up in sort of one position in the image. Hard to say. I'm going to get Deep Sky Stacker fired up and get this image here loaded into it just to be ready. Another minute till the next image. See what it brings. Yeah, why the curvy trails? So the curvy trails are stars, background stars. The telescope is tracking where it expects the asteroid to be based on its orbit, and so the stars will trail. And that actually shows you how quickly the asteroid's moving. The asteroid should be a fixed position, a fixed star-like object in the image. Yeah, as far as the name goes, it's systematically named. 2018 for the year it was discovered, of course. The V designates the part of the year that it was discovered. I think it's the half month. And so then the X, I think it's the X1, is the order of discovery within the section of the year that it was discovered. So it's sort of just how it came out in terms of whoa, wow, that star's really bright. Wowzers, it's really bright. Stupendously bright. Okay, let me just pull this second image now into the Deep Sky Stacker. Just see what I see. See, the thing is, because I haven't moved the telescope. I mean, the telescope's moving to track the asteroid, but it should be in a consistent position in both images. So I'm hoping by flipping between them, I'll be able to find something. That's interesting. Maybe. That's iffy. Huh. That's iffy, but maybe. It's better than nothing, I guess. Let's just see what that looks like and come back into CCD soft here. Yeah, I don't know. Okay, the only thing I can see that might be it, which now that I zoom in, I really don't think it's anything. I think it's just random noise. That almost looks like something, only because when I page between the images... Let me see if I can share the screen for Deep Sky Stacker. Okay, I can do that. Turn off the camera control window for a second. Okay. Unfortunately, I guess you guys can't see my mouse cursor. It'd be nice if you could, but you can see the little box up in the top left there. That shows where my mouse cursor pointed. So, right there where the crosshairs are pointed, keep an eye on that part of the image. It's actually, so you see the end of this really bright star up at the top right of the actual image, the big window. You come down here to the left a little bit, there's this little spot right there. Okay, now watch what happens when I page between them. It doesn't look like there's anything there, at least I didn't think so at first, but then in this previous image, there's this section. So the stars are all trailing from top right down to bottom left, okay? That's kind of the direction they're moving. And actually, no, I see something even more interesting. Maybe. I don't know. That might have been a single pixel. Sometimes the zoomed out view of Deep Sky Stacker makes things look more like real interesting targets than they actually are. Yeah, there's nothing there. There's just random Deep Sky Stacker stupidity. But what I thought was interesting was this trail star right here. It should be moving from top right down to bottom left, right? There's this little trail to it. Let me see if I can enhance the contrast some more. It's about as good as it gets, I guess. I made it worse. Let's see if I can bring that in. Really enhance the heck out of the contrast. Okay. So, it looks like maybe something is moving from left to right here, and that can be due to the tracking sort of gradually locking on to the asteroid. It can drift a little bit left to right, so sometimes that's kind of the giveaway that you found it. But that could just be random noise as well. So it might just be my imagination. It's really hard to do. It's really hard to do with really faint asteroids like this. They are extraordinarily hard to find with a telescope this size. Okay, let's go back to the current live images. Back to CCD soft. Okay, so we got this really bright star here, and actually something happened there with the telescope tracking. You can see how all the stars have this hook shape, so something went terribly wrong there with the tracking on this image, and the telescope sort of reset itself for where it was pointing. That can happen occasionally. But that makes it really confusing when trying to find an asteroid in an image. Arc. Okay. Just for fun, I'm going to go back into CCD soft here for a moment. Load that image up as well. And just see if anything jumps out at me.
The other problem is, even if that thing I was looking at before was an asteroid, it's so close to that super bright star that it's actually in the glare. If it were there, I can't even tell. I don't think it is, though. I don't think that is anything. I'm just looking anywhere else I can in the image. Anything that looks promising. Right now, that's looking like a big fat no. Yeah. Yeah, I think we're back to square one, unfortunately.
Alright, well, I'll wait for one more image, and if we don't find it, we'll just move on, look for another asteroid. So, the scope here is an LX200 Classic. This is an 8-inch Schmidt Cassegrain. And the Etch-a-Sketch look to the stars, it's really because this telescope was designed in the early to mid-90s, or it's probably designed well before that, but it was sold originally in the early to mid-90s, before most people even had the internet, and so it wasn't designed with computerized control in mind entirely. I mean, it does support computerized control through a serial connection, but the command set it offers is extremely limited. And part of the problem is that the coordinate format that you can send to the telescope is extremely coarse. And because of the way the right ascension and declination coordinate system works, right ascension is specified in hours, minutes, seconds. Declination is specified in degrees, minutes, seconds. Well, there's 15 degrees in every hour of right ascension, and you can only specify to the nearest second of right ascension. You can't specify to fractions of a second. So you end up with a coordinate that you're sending to the telescope that is 15 times, up to 15 times more coarse in right ascension than it is in declination, and this causes this jerking motion from left to right in right ascension. That's kind of the long and short of it. Newer telescopes don't necessarily have that limitation, because newer telescopes will oftentimes let you directly specify the drive rates. The problem is this telescope doesn't. It doesn't let me tell it, turn at this speed in this direction and at this speed in this other direction, or in two axes. You can't do that with this telescope. It just doesn't support that. It's not even supposed to be capable of doing what it's doing right now. It's just sort of fortunate that there's a workaround that I've implemented to be able to do this. It has its limitations, and that's why the stars look jaggy. With newer telescopes, though, that's not really a limitation. So the software also supports newer telescopes through the ASCOM command set. So most Celestron telescopes support that, using what they call the move axis command, or move axis method. So the NextStar SE series, for example, all of the telescopes in that series, even though they're pretty affordable scopes, really, they support that advanced capability of directly specifying the drive rate. So you don't have to fool around with that kind of workaround where you get this jaggy response. Now, that's not to say the motors themselves won't have that problem just due to periodic error and other things, but it probably won't look this severe, I'm guessing. That's something I'm going to have to try. and we'll just have to see how that goes. The telescope I have now, the Celestron Nexstar, is a small, cheap one. It's not fancy enough to be able to detect this asteroid for sure. Even with my scope here, the 8-inch scope, it's stretching it quite a bit. Okay, let's take a look at this image and just see if there's any indication of where this asteroid is. Yeah, that's... That's most likely nothing. Not seeing anything that's really characteristic of an asteroid. In the view. Thing in this latest image, which is about to not be the latest image, is right around here, but that doesn't look like anything. So part of the problem is this really super bright star is blinding the telescope right now. Huh. What's this? What's this? What are you? Is it just a hot pixel? What is that? Yeah, it looks like a hot pixel. It comes out of nowhere. And it stays, but it looks like a hot pixel. Sometimes, again, in that Deep Sky Stacker preview window, things can look like they have a point spread function, even though they really don't. Just for fun. Let's take a look here. Where's CCD soft? Here we go. Yeah, no, that... Although that's not solid white like some of these other hot pixels. This is what I was seeing in Deep Sky Stacker for a moment, this guy right here. It looked fuzzier in Deep Sky Stacker, but it's definitely a solid pixel. It's real sharp. It doesn't have this kind of point spread function you'd expect to see. So I don't think that's anything on
unfortunately.
Oh well. Did our best on that asteroid. Okay. Well, let's see what else is out there that might be interesting. I've got some ideas, but I'm not sure that they're available targets right now, so let me see what is available in terms of targets. That's a good idea, but that's not high enough yet. That's an interesting one. Not sure if it's high enough, though. No. Darn. Not quite high enough. was just looking at something there that looked like it might be something interesting. Ah, here we go. Well, I'd like to look at Eros. If you watch the series The Expanse, you're probably familiar with that asteroid. But at the moment, it's a little too far in the northeast. I kind of need it to be closer to due north, which will happen later tonight. But in the meantime, we can do this one. Gaspra. It's the third closest asteroid to Earth right now, according to Sky Safari, but my Sky Safari on my phone doesn't have all these near-Earth little asteroids like that, so it's not counting those. And it's really not that close at 100 and... Jeez, is that right? Yeah, I guess that's right. 140... about 145 million kilometers. But, hey, whatever. Let's see if we can find it. It's not moving terribly quickly relative to the stars, so this will be interesting. Let me get the orbital elements for that loaded in real quick. Stop the tracking, stop the imaging here as soon as this last picture finishes in 17 seconds. Just in case. I mean, I'll probably do a quick stack of these images just to see if there's anything that comes out of it. I don't think there will be, but it's worth a shot anyway. In the meantime, let's get Gaspra loaded up. Okay. Okay. Should be on target. We don't need to do ridiculous 5-minute long images now. We can probably get away with 30 seconds. And choose the name. This is going to be Gaspra. And start taking pictures. Okay. See anything. Just a couple stacks of the images that we collected. I don't really see anything obvious for sure. if I take it into Pixel Sight, do a longer stare. Okay, well, let's see here. For the moment, let's take a look for Gaspra. So, what have we got? Just check the pointing accuracy here for a second. Let's just see. Try to go into these coordinates real quick. Oh, probably help. Okay, first of all, stop tracking. It'll help if I plug the hand controller back in. Now that should put one of the stars of Pisces in the view. Let's see if how it did.
Yeah, it looks like it did it.
It's up there at the top, but it's there.
Yep, that's it.
Okay. Let's go back to Gasper.
Let's just do a 1 minute image.
Just see how that does. Now this is a much further away, much more distant asteroid, so it won't appear to move as quickly against the background stars. Curious thing though is that I'm having trouble lining up my view here. Let me see if Astronomy can help out here at all in terms of figuring out what I'm looking at. So I bet it's that bright one on the right, but I'm not sure. Yeah, this is using my tracking software, although for this, I mean, this asteroid's so far away, it doesn't even really need the tracking software, it's such a slow mover. Dan, Planet X is not a concern. If there is a Planet X out there, it's way out beyond Neptune. No need to worry about it. Even if it were at perihelion, it wouldn't affect us. Well, maybe that is it. It's hard to say. Okay, what does astrometry say? Astrometry says it had success finding the coordinates. Okay, cool. Now... Okay, it's not that bright one. In fact, I don't see it in the image. Okay. Huh. I don't know why the image is lining up here. Thought I tested the go-to accuracy and it seemed okay, but maybe not. Okay, let's see here. I need to... Oh, whoa, what are you doing? My app started acting up. Okay, J2000 coordinates, what are we looking at here? 714. Okay, but that's not too high. Maybe we just need to expose deeper? Let's see. We download the astrometrically solved image and just plug in the actual coordinates here. Sure, do that. That's fine. Whatever. And then DS9V6. I'm just going to check the coordinates of where the asteroid should be relative to the astrometrically solved image. I just astrometrically solved the image. It's up there right now. Let's just see. Okay, let's plug in the coordinates where the asteroid should be. Where is it relative to the field of view? That's the question. 10, 13.4, 7, it should be 14, 7 degrees, 14 minutes, 3.9 seconds declination. Okay, it's up at the top of the view, the very top of the view. The very tippy top of the view. Okay, so if that's the case, let's move it down. I don't know if this is going to be the right way or the wrong way. We'll just see. I moved it 60 arc seconds south, but that it might actually be an inverted image. I'm not sure. Let's find out. No, that's the right direction. Just needs a lot more of it. Let's see here. Let's go for 5 arc minutes, and then we'll probably move it a second time. What's the altaz for this object and what latitude? Well, I'm in Florida. The altaz for Gaspra right now is altitude 57 degrees above horizon, azimuth 238. Dan, why do you have to be like that? Come on, man. We're just trying to have a good time here and enjoy some real astronomy. People are going to be disruptive. I might just have to kick them, not because I'm scared. I just don't want to deal with the nonsense. Okay, let's try moving things east. No. Not east. Let's try west. Okay, Dan. You're gone. Yep, he just turned full-on troll there. Okay, that's better. Now we can actually see the asteroid. So, if I'm looking at my star chart correctly here, and I think I am, does that all make sense? Yeah, that kind of makes sense. I think the asteroid's right about here. It's a little hard to tell just because the stars are still streaked a little bit. Hopefully this next picture will come out a little better. So I believe this asteroid's in the main asteroid belt. It's in the constellation Pisces. Alright, I'm going to upload that new picture to Astrometry and just do one more confirmation of its coordinates. No? I don't see it. Why don't I see it?
It's curious.
Let's just make sure we're at the right coordinates. Okay, open that up. Okay. Now, current coordinates. Oh, goodness, bro. Seven. Oh, 2.5. Huh. Yeah, there's nothing there in the image, which probably means we're just not exposing deep enough to pick it up in 1 minute. It's in the right position, it's just not exposing deep enough. Let's try 2 minutes. Go for it. Let's see what happens with a 2-minute exposure. If we pick it up at all. This is actually a single-shot color camera, but I'm bending the pixels 2 by 2, so you can't decode the color from it. It becomes a monochrome image because you're putting the pixels together. The way color cameras work, single-shot color cameras assign various colors to each pixel, so red, green, or blue in a matrix pattern. When you start grouping them together, you can lose the color data, as is happening here. And I'm doing that for sensitivity purposes, really. Let's see what happens after the dark frame subtracts the hot pixels and such. While it's shooting the dark frame, let me just check and make sure that I'm not getting dew on the front of the telescope. See how things are looking over here. The ground is really soggy, but the telescope's nice and clean. No dew on the telescope. Oh wow. Plane flying overhead. He's got his front lamps on it, so you can see the beams shooting across the sky from that airplane. This is an 8-inch LX200 Classic that I'm using right now. Yeah, dew is a given in Florida. Kendrick dew heaters are a lifesaver. Alrighty. Still tough to see anything of significance here. Maybe I need to go to 1x1 binning. I'm honestly a little bit surprised. Okay, let's go to 1x1 binning. Take a 2-minute picture. This is going to be risky. The tracking is probably going to be terrible because I'm in alt-az alignment. I'm not polar aligned. This asteroid's moving slow enough that a polar alignment here would help, but I'm not polar aligned at the moment. I'm still honestly a little surprised it's not picking it up there in that latest image. That one looked good, the 2-minute exposure, 2x2 binning. Upload that one to NEOTraker.net and just check, but I'm pretty sure it's not. Pretty sure it's not there. Let's go observer. Just see. Could possibly be that Sky Safari is not quite accurate enough for what I'm trying to do with it. Yeah, that looks like it could be the case here. I might have been fooled by Sky Safari, looking in the wrong place in the image. Alright, let's try using JPL. Oh, it's right there, according to JPL. It was staring me in the face the whole time. Is that really the case? Yeah, that's the case. There it is. Okay. Duh moment. It's right there. Okay, I didn't need to go to 1x1 binning then. And yeah, the tracking on that is pretty awful. We'll go back to 2x2 binning. I think I was even picking up in the 1-minute exposures, so don't need to go as deep as 2 minutes. Alright. Yeah, Yeah, Sky Safari is good enough to get you close, but it's not dead on accurate. As usual, JPL has it more accurately. And the asteroid is right here. This actually is not a hot pixel, that is the asteroid. There's a hot pixel next to it right there, but this right here, that guy, that is the asteroid. Gaspra. Great. Okay. Let's see how that looks after the dark frame comes in. Hooray, we found an asteroid. Oh, well thank you, Copernicus. Yeah, it was fun going out there doing that with Red, tracking the asteroid, tracking the space station going across the moon. Pretty soon I'll be tracking the space station going across the night sky directly with my software. So yeah, there's an asteroid. Let me see if I can make the image not look quite so ugly. There we go. That's a little better, a little nicer on the eyes. So the asteroid is this little guy, oops, right here. Right there. It may not be VX1, but at least it is an asteroid. It's better than nothing, right? 145 million kilometers away. We can get on Eros in a little bit. Eros, it's a lot closer than Gaspra. So, that's a good question. What is the size of Gaspra? I think we actually have a pretty good idea on this one. It's 16 kilometers diameter. And I think it has been visited by a spacecraft. Oh wow, Galileo nonetheless. Galileo's spacecraft on its way to Jupiter flew by this asteroid in 1991
passing within 1,600 kilometers. And it was the first asteroid to ever to be closely approached by a NASA spacecraft. It's pretty cool. Let's see. Try to share some of these images with you guys. No? It doesn't let me do that? Well, that's a shame. Oh well, so much for that idea. If you Google it, they're out there. The images are pretty easy to find. Cool, well, accidentally visited a historically important asteroid then. Meantime, I am going to start getting ready to go to the asteroid Eros. Also, I don't think I've quite finished the latest season of The Expanse yet, so if anyone in the chat ruins it for me, spoils anything, I will boot you from the chat. Just saying. Just saying now. In the meantime, I am going to download the orbital elements. Alright. We can try now to see if we can get a different asteroid. Let's see what happens. This may end up pointing at the wall of my house and not at the asteroid. I'm not sure. Let's see. Alright. Gotta get my flashlight out for this. Make sure I don't pull a cord or anything. Here we go.
That's really cutting it close to the edge of the roof line. I'm not entirely sure I'm not pointing at the edge of the roof line. Let's find out. Whoa. Oops. Oh, that was silly. Oops. I accidentally took a, Okay, well... I accidentally had a subframe selected, so it didn't take a full-blown image. Alright, let's just take a 1-second picture, see what we're looking at. We are looking at the edge of a roof, I guess. Or not? I'm not sure why it came out pure white there. Oh, I know why. Yeah, okay. I just had to reset the levels. It wasn't automatically resetting. Okay, let's go for a 1-minute exposure now. Oh, and I should probably retitle this picture. This is no longer Gasper. There we go. That's better. So, if you haven't seen it, I highly recommend checking out the TV show The Expanse. It was on the Sci-Fi Channel. Now it's an Amazon series. It's probably the best hard sci-fi I've seen on TV in a long time. That is to say, they don't go overboard with the hand-wavium in terms of the technology. It's not exactly current tech, but it's sensible future tech for the most part. There's no artificial gravity except by spinning a station or accelerating to create gravity on your ship. Otherwise things and people just float. And trips between asteroids or planets take weeks or even months of time. Okay, let's reset the levels. Hey, we're in luck. We're not looking at the roof line of my house. Okay, that's good. So, what are we dealing with here? Could just wait for the auto dark to take, I guess, but let's just see where... What does Sky Safari say? Okay, let's just see. Let's see what astrometry says. That's going to be more accurate anyway. Wait for the auto dark to take before I try to solve it. Okay, that's better. Astrometry solving the image eventually. It's being slow tonight. Come on. Don't fail me now, astrometry. If worse comes to worse. Oh, it's solving now. That's good. I was going to say, if worse comes to worse, I can always throw it on the desktop to solve it, but it's done. Okay, good. I think that's it right there. Ooh, yeah, I'm pretty sure that's it. Okay, I'm pretty sure that our asteroid is right here, almost dead center. Right there. There's the real Eros. Okay, let's see. Just to make sure, though, I'm going to load the astrometrically solved image up and confirm the coordinates. Yep, that's our boy. That's the one. It's right where it should be, according to JPL. Excellent. Excellent, excellent. Now again, this is not a terribly fast mover, but it is considerably closer than the previous asteroid we were looking at. So, according to Sky Safari, right now this asteroid is 56.7 million kilometers away, or about 3 light minutes. So what you're seeing on the asteroid happened 3 minutes ago. So at least this one's considerably closer than our Sun, but still quite far out there. So, yeah, the interesting thing about this asteroid, it was the first discovered near-Earth asteroid. It's the first asteroid discovered that can actually pass near to Earth and cross the orbit of Mars. So it doesn't hang out all the time in the main asteroid belt. What is its perihelion distance? 1.13 astronomical units, so just outside the orbit of Earth, which makes it a more Mars crosser. In terms of its physical size, it's a beefy beast. It's 16.84 kilometers long, or wide. It's kind of a lumpy potato shape. Yeah, so again, as you can see, the stars are actually gradually rotating here. This is field rotation because I'm not polar aligned right now. I'm tracking on the asteroid directly, so it stays pretty much stationary. But the stars will appear to rotate around it due to the field rotation from altitude-azimuth alignment. This is why amateur astronomers who are doing serious deep space astrophotography polar align their telescopes so that the telescope only has to turn on one axis to maintain tracking of the stars. Another plane going overhead. Because by doing that, by polar aligning, you get rid of that field rotation. I wonder how bright this asteroid is right now. According to Sky Safari, magnitude 10.6. So still significantly dimmer than anything you can see by eye, but for the telescope, not bad. Easily detectable compared to, say, close to magnitude 17, where you're really pushing the telescope's limits. That's why we weren't able to detect 2018 VX1 earlier. I think that was the main reason. Pointing accuracy might have been another factor. I picked two stars to align on that were pretty close to each other, which is not ideal. So that's cool. I'm really glad I got to see this one. I think this is my first time looking at, well, maybe not. I don't really recall imaging Eros before. So this might be my first time tracking this particular asteroid. Thanks for coming, Troy. Hope you enjoyed it. There's a bit of light pollution out tonight. Usually I don't see much, but it's Friday night. There's probably a lot of high school football stadiums, their lights still on. I don't know. And I'm really tempted to go after Comet 46P. That's supposed to be a good one right now, I think. But it's kind of low for me in the south. Negative 32 degrees declination. And unfortunately, where I've got the telescope set up right now, I don't think it's going to be above the trees. Hey, thanks for coming by, Dick. I hope you have a good night. Could always knock out a couple Messier objects just for fun, something like that. But yeah, just a reminder, if you want this asteroid tracking software, the source code is on my GitHub page in the video description. NEOTraker is what I'm currently using, and I've got a video showing how to use it and all of that on the channel as well. And if you like it, if you want to see more of it, please consider donating. Helps keep the channel going, helps keep me going. I enjoy doing this kind of stuff, but it's not a free hobby, especially when you're picking up new equipment to test out software. Oh, a good light pollution filter? Oh, that's a good question. I would recommend an Astronomics. Is that the one? Yeah. Astronomics. Narrowband. Narrowband nebula filter, or maybe a UHC filter. UHC narrowband astronomics, 1 1/4 inch. That's a $72. That'll set you back about $72, 73. I think I've got one of these. I don't really use it anymore. It helps if you're doing visual observing, but if you're doing photography, it's not really much of a help. I mean, if you really get into narrowband imaging and you do single real narrowband imaging, one filter at a time, it can help. But not with the single shot color camera so much. It's not ideal for that. No, Wolfie didn't contact me, but it's okay. He's probably busy, and I ended up... I got the Celestron scope he has anyway, so I picked that up. I'm selling my old solar scope, my Coronado PST, to fund it, but the Nexstars are on sale right now, so if you are considering getting a Nexstar Celestron telescope, now's a good time. They're on sale. So I picked up the 4SE, which is what he has from what I can tell. And I've tested my SatTraker software on it. It seems to work. I fixed a bug, actually. I found a bug with it when I tried it. Fixed it. Seems to work now, but I need to actually test that in the field. Now's not a great time because it's too late at night. Low Earth orbit satellites aren't visible, but early morning or early evening hours would be ideal. So perhaps later this weekend I'll give that a shot. I probably will. Though I need to figure out a good way of mounting a camera on top of it. Is it this year that Asteroid Apophis will be close to Earth? I don't think so. Not really. Let's see, when are the close approach dates for that one? That's not what I was looking for. Well, fine.
So next close approach to Earth is in 2020, and it's not all that close. On October, looks like October 12th, 2020, it'll be within 0.2 astronomical units, 0.21 astronomical units of Earth. 2121, it gets a little closer, 0.11 astronomical units. But the really, really close approach everyone's looking forward to there is 2029. 2029, that's when it'll be whizzing right by Earth. And I think it's large enough and close enough that it will actually, I want to say, be visible by naked eye if you're in the right place when it's passing by. I'm going off memory here, but I want to say that at that point it'll actually be so close you'll actually be able to see it, which would be remarkable if you know right where to look and you have dark skies and all of that, all those caveats. But I kind of promised myself years ago when it was discovered that it was going to be making this close pass in 2029, I was going to save my money and travel out to Russia or wherever I have to go to see this thing. And I would definitely bring a telescope along to track it. Actually, this little Celestron scope I've got now would be perfect for that. Will my software work with the CGX? I believe so. I do believe so. It should work with any Celestron scope whose hand controller is version 1 or is 1.6 or newer. Let me see here. Where's the README for that ASCOM driver for Celestron? I don't want to have to download it again. Where is it? Where is it? Let me see. Sorry, give me a second. Let me see if I can find the README file for the ASCOM driver for Celestron. I need to just save that somewhere handy because I keep referring to it. And I don't know where I put it. I really ought to keep track of that. Oh, where did it go? Oh, good grief. Computer's taking forever to refresh the download directory. That's the ASCOM platform installer. Where's the Celestron driver installer? Celestron ASCOM driver help. Here we go. Okay. Okay, so yeah, the only ones that it really shouldn't work on are GT scopes for Celestron. In early GPS scopes it says fork mount never has GPS. 1.6 starts with the GPS scopes, fork mount always has GPS. Then you have the I-Series, that'll work. I-Series SE, that'll work. ASC, GEM mount, always polar aligned, may have GPS, that'll work. CGE series, GEM mount, always polar aligned, may have GPS. CPC series will work. So the CGX, what does that fall under in terms of the hand controller for the CGX? CGX, if you just got it, it should definitely work, I think. And that's a Celestron mount, right? If I'm not forgetting. Yeah. Yeah. CGXL. Mount and tripod. And that's a beast of a boy, isn't it? What kind of hand controllers it got on there? Give me a close-up picture. I want to see. Arg. What do they call it on the hand controller? They just call it CGX or something on the hand controller? That's a nice looking mount. Yeah, it doesn't show me a close-up of the hand controller. Yeah, that's a nice looking mount. I'm 99.9% sure it will work with that. I can't imagine that it wouldn't.
It's got to. It's just got to. So yeah, you could definitely try it with that. Now, in terms of the sat tracking, at the moment it won't, because the sat tracking requires altitude azimuth for the moment, but that's a very simple fix to correct that, to give an option for equatorially mounted telescopes. I pretty much just have to almost do a find replace on alt-az to RA dec, and it'll work. So that's something I hope I can do this weekend if I can find the time. Should be a pretty simple fix. Oh, I have a CA Edge HD. Those are nice optics, yeah. Yeah, so that should definitely work. I can't imagine it wouldn't. You will need, for the satellite tracking, you'll want to have a camera piggybacking on top, some sort of viewfinder camera. It could be even a guide scope camera, but you want a wide field of view, if possible. And it ought to be some sort of webcam style imager that Windows recognizes as a video camera. It could be, you know, man, I'm going to date myself here. It could be a 2U cam or whatever. I use a video capture card with a Samsung SDC 435 security camera. It's pretty cheap, and it's effective for this. But you could use some sort of guider camera. Trying to think of a good example. I mean, people have asked me before if they can use like some of these high-end planetary imagers and stuff. I wouldn't recommend it. You don't need overkill resolution on the guider camera, and in fact that'll just make it more work for the computer. There'll be more pixels to process, and so that's just going to slow the program down. I would recommend using a low resolution, just a simple cheap camera, some sort of webcam style imager. You know, Meet LPI or planetary camera from Celestron, whatever your poison is, and then just slap that on some wide-angle lens on top of the scope to do the guidance on the satellites. That's my recommendation. Oh, that's maybe the reason I'm seeing so much light pollution. It feels, I think, fog is moving into the area or something. Cloud cover, it looks like. It's reflecting the street lights in the distance. Yeah. So, alt-az would probably be more convenient for satellite tracking. I mean, depends. If you're permanently mounting that CGXL, then that'll be more convenient. It just depends on what you're doing, I guess. For me, it's just so much easier and simpler to just throw it on alt-az if I'm just doing satellite tracking. Plus, for the LX200, it's more stable anyway. On the Wedge, there's more vibrations. So take that into account too. What's the maximum slew speed of that CGXL? Do you happen to know? I don't know. Slew speed. Because that's the one area I'm disappointed with the Nexstar. The only thing, if I had a complaint, is that it's only like a 3 or 4 degree per second slew speed. And it looks like, yeah, it looks like CGXL is the same. Slew speeds 4 degrees per second maximum, 3 degrees per second is the default, so definitely bump that up to the maximum, get 4 degrees out of it. My LX200 Classic will do 8 degrees per second, I think. It's around that speed. It's snappy fast compared to the Nexstar or the CGXL. So just keep in mind, I mean, put it this way. The space station, if it's directly overhead, in its low Earth orbit, it'll be traveling about a degree, anywhere from a degree to maybe 1.5 degrees per second. So in theory, it could keep up at 4 degrees per second, but it's not going to be able to catch up very easily if you're way off on the start of the tracking, right? So you kind of want to pre-position the telescope so that it's in the area of the sky where you're expecting the satellite to show up before it starts to show up, just so that you're ready. So like with my scope, I don't even usually think about that, because it could be pointed at the opposite side of the sky almost, and it wouldn't matter. It'd get there in 30 seconds or less. If you're traveling at 4 degrees per second, though, you want to be in the right ballpark at least, right? So you just want to look on heavens above or whatever and just be aware of where the satellite's going to appear, and just position it close to that before you start tracking. So that's the only tip I've got there. I'm looking forward to trying it myself with the Next Star. It'll be the same slew speed as your CGXL, and just see how that does. Oh, got a bright frame there, huh? Whatever. Okay, so I guess that's gonna just about do it for this stream. We really do have clouds moving in. Wasn't expecting that tonight, but hey, such is life. But we got to see a couple cool asteroids at least, and let's verify the tracking software is working well. I'm gonna stop that. Stop the tracking. And thank you all for coming, and I hope you enjoyed the stream. Again, please check out the software, and if you've got a scope that can use it, give it a try, and let me know how it goes. Oh, almost forgot. I should have announced this at the beginning of the stream. I've got a web forum up for reporting bugs and also reporting success with the software I'm developing. So I've got 2 of the 3 modules available now. That's the NEOTraker and SatTraker, and I'll be making the UFO tracker next for tracking rockets and other fast-moving objects. And I'm basically putting this all under the umbrella of what I'm calling the TeleTrak suite. So the original alpha version of the software I called TeleTrak, and now I'm breaking it up into these 3 modules, but as a package for all 3 modules I'm calling it TeleTrak basically. It's just that it's really a suite of 3 different modules that are all separate. So go check out the forum, and if you do happen to have a chance to try the software, let me know how it goes. You can post in the forum there. I've got 2 subforums set up for the 2 modules I've released so far. If you have success, let me know there as well. And if you have any issues or any bugs that you need to report, you can do it there. If you're not into GitHub, software is up on GitHub, and you can issue pull requests, of course. But if you're not familiar with all that, or you don't want to set up a GitHub account, you can also make reports and also share images. That's the nice thing about the TeleTrak Forum website. It'll be easier for us to share images of things we've tracked or videos that we've captured of various things tracked. So go check it out, and let me know how it goes. Alright. Yes, and thank you, Sam. Subscribe for more, and hit the bell icon so you get notifications of these live streams when they happen. Alright, I'll see you guys later. Have a good night.